The latest release of SmartCAM delivers functionality designed to make it even easier to work with solid model data. These functions help you to easily position geometry, tooling and fixturing, and to interrogate model dimensions in 3D space. The first feature we'll take a look at is the Conic Center Snap option. You can enable or disable it by using a checkbox on the Display Modes control panel. Let's turn it on to explore how it is used. We'll zoom in closer to this model and see it in action. It is used in conjunction with the center point snap being enabled. Let's turn that on. Now, whenever I position the cursor near to an appropriate feature of the model, center lines and center points are highlighted and which can be snapped to. The function is designed to be used with wireframe geometry as well as with solid model information. Let's remove the solid model from the display and look at a wireframe line arc view of the same component. We'll flip to the plan view so that we can clearly see the use of the function. The coordinate positions of arc centers are highlighted as I move near to them. Each can be snapped to. We'll revert back to a solid model view of the component so that I can introduce another useful new function. SmartCAM can project free coordinates, cursor inputs that are anywhere in 3D space and not necessarily on the geometry, onto faces of the solid model. This feature is enabled by a checkbox in SmartCAM's Increment control panel. It can be used for a number of tasks by the SmartCAM programmer. The first we'll take a look at is how it can be used to sketch geometry items onto a planar face without the need to set up a work plane in advance. I'll just draw some lines in 3D on this planar face of the model. Because free projection is enabled, a point on the face is selected. We'll just add a couple of more lines to show it again. The next benefit of this function is to make it easy to align wireframe or model geometry. I'll just turn on a layer that contains a clamp item which has been merged into the model and that is placed at no particular location. We will move the clamp face to a suitable location on our component. Using free coordinate projection, we can select a from position on the clamp face and a to position on the required face of the model. A front view of the model clearly shows the Z placing of the clamp relative to the component. SmartCAM's Conic Center Snapping and free coordinates projection can be used to measure and check dimensions on solid model data. Let's look at how easily we can do that by checking some of the features of this solid model. I'll adjust the view of the model a little and enable center snapping. First, let's interrogate the dimensions between two of the holes in the base of this component. Snap to the conic centers of the bottom left and top right holes, and SmartCAM displays the X, Y and Z incremental dimensions between the two holes. We can see that the X spacing of the two holes is 158 mm and the Y distance is 84 mm. We're also given the linear distances between the snap points in planar 2D and 3D space, plus the planar angle between the two positions. You can see that we're able to easily calculate orthogonal values from 3D snap points. Here's another example of using these features. We snap to the conic center of the bottom right hole, then use a free coordinate projection onto this vertical face. You can clearly see the 3D vector between the two selected positions. We can see that the whole center is 18 mm away from the vertical face in the x-axis direction. And a couple more examples. From the plan view of the component, we measure from the implied corner at the top left of the part to the center of one of the bores in the middle of the component, and then check the distance between the two bores. Back to the isometric view, and we check the angle of this face. Snap to two free coordinates on the face, and we can see that it lies at an angle of 45 degrees to the horizontal. Finally, I will show you that element data reporting on analytic surfaces has been improved. Let's take a look at some of the features on this caliper component model. Get element data for this face, and we can see that it is a toroidal, donut-shaped surface with a section radius of 3.5 mm. Here's another toroidal surface with a section radius of 2.5 mm. This conic face has a diameter of 359 mm, and this surface has a spherical radius of 16 mm. The conic face beside it has, logically, the same radius. That concludes our demonstration of SmartCAM's new conic center and free coordinate projection functions. We have seen how we can quickly and easily check and measure data from solid models, and how these functions can be used to manipulate and position 2D and 3D geometry in 2D and 3D space. SmartCAM lets you quickly and easily generate a toolpath for your solid features without needing wireframe geometry, providing you complete control over your toolpath.